Welcome to the deep dive. Today we're diving into something that, well, many are calling a fundamental game changer in technology. We're talking about how artificial intelligence is moving out of these, specialized labs and into the hands of just about everyone. It feels like it's sparking a really profound shift in innovation, in business, and even how individuals like you and me can leverage powerful tech. I'm genuinely curious to unpack what that truly means for us all.
It's a fascinating evolution, absolutely. And this transformation, this is what we're calling AI democratization. Our mission for this deep dive is really to unpack what open truly means in the AI space. We want to understand its far-reaching impact on everything from enterprise IT to job markets. And ultimately what it means for you, the listener, as you navigate this rapidly evolving landscape. We'll be pulling the most important nuggets from a comprehensive analysis titled Open Source Generative AI Analysis.
Okay, so this idea of AI democratization, I like that term. How exactly is it happening? It's built on some foundational pillars, right?
Exactly. Yeah, think of AI democratization as resting on, say, four key pillars. They all work together to put AI's power into the hands of the many. It's about lowering those technical, financial, and educational barriers.
Barriers that used to be huge.
Huge, yeah. The first pillar is enhancing access through user-friendly design. Historically, you needed pretty extensive programming knowledge just to touch machine learning systems. It was really complex.
Oh, I remember that phase. Definitely not for the faint of heart.
Right. But now we're seeing intuitive low-code or even no-code interfaces, drag-and-drop visual programming, and increasingly natural language interfaces.
So you can just talk to it.
Pretty much. It means you can build, train, deploy models, or query data simply by asking questions in, plain English. This effectively removes the coding barrier for a huge part of the workforce.
That's a massive leap. I mean, I remember trying to get into AI years ago, and it felt like I needed a dozen PhDs just to get started. So this low-code idea really speaks to me.
It's a game changer for access.
But what about the cost? AI always seemed incredibly expensive. Was that just perception? Or...
No, it was very real. And that brings us nicely to the second pillar, affordability.
Yeah.
Developing sophisticated AI used to be a super capital-intensive endeavor. It demanded massive computational resources.
Okay.
But today, AI democratization is dismantling this financial barrier too.
Well,
We have free or subsidized access to infrastructure via scalable on-demand cloud platforms. Think AWS, Azure, Google Cloud. They handle the heavy lifting.
so the infrastructure cost is spread out.
Exactly. And even more critically, the proliferation of powerful open-source frameworks like TensorFlow and PyTorch, along with pre-trained models on platforms like Hugging Face, that eliminates those prohibitive licensing fees.
Ah, no big upfront software costs.
Right. This truly levels the playing field. It makes powerful AI accessible even for smaller organizations or startups.
Okay, so we've got easier access to the tools. They're more affordable. But tools are pretty meaningless if you don't actually know how to use them, right?
Precisely. Which leads directly to the third pillar, bridging knowledge gaps through widespread education. This isn't just about the tools themselves. It's about cultivating AI literacy across the board.
Making people comfortable with it.
Exactly. And there's a really rich ecosystem of educational resources now. Online courses from platforms like Coursera, edX, Udacity, workshops, extensive vendor documentation.
Stuff you can access from anywhere.
Pretty much. And beyond formal education, you have these vibrant open source communities, Stack Overflow, GitHub. They facilitate collaborative problem solving and knowledge sharing. People learn from each other.
Okay, that makes sense. Access, affordability, education. What's the final piece?
The fourth pillar is data democratization. AI models, fundamentally, they depend on data. They need it to learn.
Right, garbage in, garbage out.
You got it. So for these AI tools to be truly useful, organizations have to establish systems and processes for easy access, comprehension, and utilization of data. And that needs to be for individuals, regardless of their technical background.
So everyone who needs data can get it, understand it, and feed it to the AI.
Basically, yes. This ensures the AI tools are well-fed, properly trained, and can deliver real, tangible value.
Wow. So when you put all those pillars together, access, affordability, education, data, what this really means is that AI isn't just for the coding wizards anymore. It's becoming almost as accessible as, I don't know, a spreadsheet program.
That's a great analogy. It's aiming for that level of accessibility.
That's a truly seismic shift for everyone then. But let's pivot a bit. What does all this actually mean for businesses? This isn't just about shiny new tools, is it? It must be changing internal dynamics, the way companies actually work.
It absolutely is. AI democratization is profoundly altering the internal dynamics of enterprises,
Hmm?
especially the role of IT departments.
Ah, IT. Always in the middle of things.
Always. As AI tools become more user-friendly and integrate into everyday applications, think, Excel suggesting formulas, PowerPoint drafting slides, or analyzing data just by asking questions in natural language.
Stuff people use all the time.
Exactly. So IT's traditional role as a technology gatekeeper, that's evolving. They're shifting towards becoming strategic enablers of business-led innovation.
Less know, more how.
Precisely. And this shift fosters faster decision-making, it accelerates innovation cycles, and it enhances overall productivity. Non-technical employees, say in marketing or finance, can directly leverage AI for tasks like idea generation, content creation, even business forecasting.
So they're not waiting for IT to build something custom for weeks.
Right. It leads to greater efficiency, more agility. It even reduces the training burden on IT for some things and can improve organizational resilience.
So, okay, this empowerment, it sounds great, but it must come with new challenges for IT, right? It almost feels like the problems just shift, maybe become more complex. What are those new responsibilities for IT leadership?
You're right to point that out. It's not that challenges disappear, they definitely transform. While some burdens might shift, IT departments now really have to pivot to address 5 key strategic challenges.
Okay, let's hear them.
First, and maybe most importantly, governance, security, and ethical use. With AI tools popping up everywhere, often without direct IT oversight initially.
The whole shadow IT problem, but supercharged.
Exactly. So establishing robust frameworks for data access, for acceptable use, and ensuring the outputs are fair, reliable, ethical. That's paramount. It includes mitigating risks like intellectual property infringement, data leakage, bias in models.
That sounds like a massive undertaking, a whole new level of complexity.
It is. Second, integration and scalability. IT is responsible for making sure these diverse AI tools integrate seamlessly into existing workflows, and crucially, that the underlying infrastructure is robust, secure, and scalable enough to handle the increased demand, because demand will increase.
Right. You don't want the system crashing when everyone starts using it.
Definitely not. Third, cost management. Now, while open source can reduce licensing fees, widespread AI use, especially on cloud platforms, can lead to spiraling computational costs if you're not careful.
The cloud bill surprise.
That's the one. IT must implement rigorous cost monitoring and optimization practices. Fourth, continuous learning and development. The AI landscape evolves at, frankly, a breakneck pace. IT teams have to stay current with new technologies, new techniques, and importantly, new security threats.
Constant learning curve.
Constant. And fifth, alignment with business needs. IT needs an even deeper partnership with business units now. They need to truly understand their goals and help select and implement the right AI solutions, ensuring tech adoption is strategically driven, not just tech for tech's sake.
So IT becomes less about just keeping the lights on, more about strategic partnership.
Absolutely. The IT function really redefines itself. It shifts from, say, tactical service delivery to strategic oversight and governance of this whole decentralized ecosystem of intelligent tools.
Okay, let's maybe zoom out a bit. This open revolution in AI, it didn't just appear out of nowhere recently, did it? It feels deeply connected to the much older open source movement in software.
Indeed. You can't understand AI democratization without understanding the open source movement. Its core ideas go way back to the 1980s. Figures like Richard Stallman, the Free Software Foundation, the GNU Project, they were all about promoting freedom.
The freedom to use, study, modify, distribute code.
Exactly. That gained huge traction with the rise of the internet, leading to massive projects like the Linux operating system, the Apache web server, things that underpin so much of the modern web.
Right. So that's one thread. What about AI's path?
Concurrently, AI was on its own, often long and winding journey. You had early generative concepts back in the 1960s, like the Eliza chatbot, then foundational research into neural networks, backpropagation in the 70s and 80s, but it was punctuated by these AI winters.
Periods where funding dried up, interest waned.
Exactly. Progress wasn't linear. A really pivotal turning point, though, came in the late 90s and 2000s. This was thanks to powerful GPUs graphics processing units from companies like NVIDIA.
Initially for video games, right?
Primarily, yes. But researchers recognized their parallel processing capabilities were exceptionally well suited for training the deep neural networks that were becoming more sophisticated. That was a key hardware enabler.
Okay, so we have the open source philosophy gaining ground and the hardware getting powerful enough for serious AI. When did these two revolutionary paths really decisively meet? That feels like the critical moment.
They converged decisively in the 2010s. I'd say that was the watershed decade. This era saw the release of incredibly powerful open-source deep learning frameworks, most notably Google's TensorFlow in 2015, and then Facebook's now Meta's PyTorch in 2016.
Those names are everywhere now in AI circles.
They are foundational.
Yeah.
These libraries effectively democratized the ability to create complex AI models. They abstracted away a lot of the low-level complexity, and they benefited immensely from global community contributions. Then, the release of influential open-source models like Google's BERT in 2018 for natural language understanding further cemented this convergence.
Okay, this is where it gets really interesting for me. When we talk about open in AI, it's not a simple single definition, is it? I hear open source, open weights, open access. It sounds like there are critical distinctions we need to understand.
You're spot on. The terminology can be, frankly, quite misleading. There's actually a whole spectrum of openness, and it matters a lot.
Okay, break it down for us. What's the most open?
Truly open source AI represents the highest standard. This aligns with the original free software principles. It means making publicly available basically everything. The model's architecture, the source code to run it, the complete original training data set.
The actual data it learned from. Wow.
Yes, plus the detailed training methodology, the code used for training. This level allows for deep inspection, checking for biases, ensuring full reproducibility. Big Science's Bloom model is often cited as trying to achieve this, but it's still relatively rare for major releases to go this far.
Okay, so if that's the gold standard but rare, what's the most common type of open that we actually see out there?
That would generally be open weights, sometimes called open access models. This is by far the most prevalent form of openness today, especially from big tech companies.
Right. What does open weights actually mean?
It involves releasing the final pre-trained parameters, essentially the brain or the weights of the model after it's been trained. These weights can be downloaded, hosted locally, and used for inference running the model or for fine-tuning on new data.
Examples.
Think Meta's Llama family, Stability AI's Stable Diffusion. These are huge. But, and this is crucial, it generally withholds a proprietary training data and often the specific training methodologies.
Ah, so you get the finished product but not the recipe or ingredients.
That's a great analogy. It's like getting a compiled software application without its original source code. You can use it, you can even modify its behavior to some extent through fine-tuning, but you can't fully inspect how it was built or fundamentally change its core in the same way.
Okay, that makes sense. And then there are even more restricted versions that still get called open sometimes.
Yes, you also see restricted weights. These are models where the weights are released publicly, but they come with significant license limitations. Maybe thresholds on commercial activity, caps on revenue, restrictions on the number of users, or specific prohibited uses.
Like that initial Stable Diffusion 3 license everyone got upset about.
Exactly. That was a prime example of a restricted weights release that caused major backlash. And then, of course, on the opposite end of the spectrum, you have closed-source API-only models.
The black boxes.
Total black boxes. Everything, architecture, weights, training data, is a trade secret. Access is only through a managed API. Think OpenAI's GPT-4, Anthropic's Claude models. This offers the least transparency, the least control, the least customization.
It's really important to understand these differences then, because open doesn't always mean what you might think.
Critically important. And what's fascinating here is this distinction, this spectra, it's actually a core strategic element for the companies involved. Well, the dominant trend among major players promoting OpenAI isn't true open source. It's what you might call strategic openness. Companies like Meta, for instance, release weights for models like Llama. Why? To rapidly build massive ecosystems of developers and users around their models.
Get everyone using their tech.
Precisely.
Yeah.
It creates network effects. It helps establish their technology as a de facto standard. They're granting access for use, hoping you'll build on top of their platform without ceding control over their most valuable intellectual property, which is often their vast curated data sets and their proprietary training methods.
So it's open, but with strategic boundaries. That makes sense from their perspective. So what does all this, the different types of openness, the strategic plays mean for the actual pace of development we're seeing? Because it feels like things are moving at warp speed lately.
It means a dramatic and, yes, definitely accelerating pace of innovation, particularly since ChatGPT burst onto the scene in November 2022. That was a real catalyst.
Everything seemed to shift after that.
It did. There's been a rapid compression of development cycles. And you see this kind of strategic call and response between the big closed source players and the open weight proponents.
Like a tech arms race.
In a way, yeah. ChatGPT created a huge sensation. Meta quickly responded with the research release of Llama in February 2023. Now, even though Llama wasn't initially for broad commercial use, its weights got leaked.
Ah, the leak. I remember that.
Right, and that leak sparked the open source community to adapt it, modify it, run it locally. It proved that a powerful, locally runnable alternative to the big API models was possible and fast.
So the community jumped on it.
Immediately.
Hmm.
Since then, you see this dynamic. OpenAI, Google, Anthropic push performance with models like GPT-4, Gemini, Claude 3, then Meta, Mistral AI, Stability AI respond with progressively more capable open weight releases like Llama 2, Mixtral, Stable Diffusion XL, and now Llama 3.
It's relentless.
Absolutely relentless. Major releases or significant updates are announced almost monthly, sometimes it feels like weekly, throughout 2024. Just look at Llama 3.1 hitting the scene in July 2024. The pace is just incredible.
Okay, let's get into the actual tools then. Let's dive into the nitty-gritty. What are the key open source technologies, the frameworks and models that are enabling this democratization, the ones developers are actually getting their hands dirty with?
Right. The ecosystem is vast and growing daily, but we can highlight some key players. First, you have the foundational frameworks. Think of these as the scaffolding, the core building blocks for AI development.
The essential toolkits.
Exactly. For deep learning, the two undisputed heavyweights are TensorFlow, originally from Google, and PyTorch, originally from Meta. These are comprehensive libraries that let you define, train, and deploy complex neural networks. They handle a lot of the underlying math and hardware acceleration.
TensorFlow versus PyTorch. That's like a whole debate in itself, isn't it?
It can be. TensorFlow is known for its robust ecosystem, great for large-scale production deployments, with tools like TensorFlow Serving and Lite. PyTorch gained immense popularity, especially in research, for its ease of use, flexibility, and more Pythonic feel.
So different strengths, maybe. What else is foundational?
For more traditional machine learning tasks, things like classification, regression, clustering, not necessarily deep neural nets,
Right.
scikit-learn is an absolute cornerstone. It's incredibly popular, very well documented, and has a simple, consistent API, essential for many data science workflows.
Got it. So those are the core libraries. But what about building actual applications on top of these, especially using the big language models we hear so much about?
That's where application frameworks come in. And for large language model, LLM apps, LangChain has rapidly emerged as a really critical open source framework.
LangChain, I hear that name constantly now. What does it actually do?
Basically, LangChain simplifies the process of building context-aware reasoning applications using LLMs. It provides modular components, they call them chains, that help you connect LLMs to external data sources, like your company's internal documents.
Ah, so the LLM isn't just using its general knowledge, it can access my specific data.
Precisely. LangChain helps manage prompts, structure interactions, even build more autonomous agents that can perform sequences of tasks. It's key for things like building a chatbot that can answer questions based on your specific product manuals or summarizing internal reports. It helps break down documents into searchable pieces the LLM can use.
That sounds incredibly powerful for making these models genuinely useful in a business context. Are there others?
Sure. Another notable one is the Microsoft Bot Framework, which is an open source SDK specifically for building, deploying, and managing conversational AI and chatbots. It integrates well with Microsoft's other AI services naturally.
Okay, framework sorted. But what about the pre-trained models themselves, the actual AI brains we can download and use? What can they do across different types of media, text, images, audio, code?
Right. The generative AI arsenal is increasingly multimodal, which is really exciting. Let's break it down. For text models, you have heavy hitters like Meta's Llama series, Llama 2, Llama 3. These are high-performance models, often instruction-tuned, making them great for conversational AI, writing assistance, summarization, all sorts of text generation. They come in various sizes, too.
Different sizes for different needs and hardware.
Exactly.
Yeah.
Then you have very large models like Falcon 180B from the Technology Innovation Institute in the UAE, known for top-tier performance. And Bloom from the Big Science Workshop, which is truly multilingual, handles dozens of natural languages and programming languages, a huge collaborative open science effort. Also efforts like GPT-NeoX and Pythia from Eleuthera AI, a grassroots collective aiming to replicate large architectures.
So lots of choice just for text. What about visuals, images?
In the world of image models, the Stable Diffusion series from Stability AI has been hugely influential. These are powerful text-to-image diffusion models. You type in a description, and it generates an image.
Often incredibly realistic or artistic images.
Yes, high-quality output and highly customizable through fine-tuning. Stability AI also released Deep Floyd IF, noted for better language understanding and, interestingly, more accurate rendering of text within images. And you see community fine-tunes like OpenJourney, designed to replicate the specific artistic style of Midjourney.
Fascinating. And audio. Can AI generate sound too?
Absolutely. For audio models, a key open-source tool is OpenAI's Whisper. It's incredibly accurate for automatic speech recognition, ASR, turning speech into text and transcription across many languages.
Whisper's accuracy is pretty amazing. I've used it.
It really is.
Yeah.
Then you have Meta's AudioCraft framework, which include models like MusicGen for generating high-fidelity music from text prompts, and AudioGen for creating sound effects. And projects like Koki offer open-source text-to-speech, TTS engines, allowing you to even train custom, natural-sounding voices.
Music, sound effects, voices. And finally, code. Can AI write software?
Yes, there are specialized code models. Projects like CodeGen from Salesforce or Polycoder from Carnegie Mellon are trained specifically on massive amounts of source code. They excel at code generation, auto-completion, and even explaining code snippets across multiple programming languages.
It's an incredible toolkit across so many domains.
The pace of development across all these modalities is just staggering.
Okay, so we have all these incredibly powerful tools, frameworks, models, many of them open in some sense. But as you hinted earlier, it's not a complete free-for-all. There's this critical legal aspect, licensing. And this isn't just some academic footnote. It dictates what an organization or even an individual creator can and cannot actually do with these models.
You're absolutely right. The promise of free and open tools is fundamentally governed by their software licenses. And these licenses are not all created equal. They dictate use cases, modification rights, distribution, commercialization, everything. Getting the license wrong can have serious consequences.
So what kind of licenses do we typically see? Is there a standard?
Not really a single standard. It's more of a spectrum. On one end, you have highly permissive licenses, like the MIT license or the Apache 2.0 license. These generally allow very broad use, modification, and commercialization with minimal requirements, usually just attribution. Many foundational frameworks like PyTorch use Apache 2.0.
Okay, those sound pretty straightforward. The do almost anything kind.
Largely, yes,
Yeah.
but then you get into more complex or custom licenses. A really prominent example in the AI space is the Responsible AI License, or RAIL. Big Science used a version of this for their Bloom model.
Responsible AI license.
Yeah.
What makes it different?
RAIL licenses attempt to combine open access and sharing with specific use-based restrictions. They explicitly prohibit certain harmful applications, things like generating misinformation, enabling malicious cyber activities, certain types of surveillance, or uses in law enforcement without human oversight.
So it's trying to build ethical guardrails directly into the legal framework.
Exactly. It's a fascinating attempt to proactively address the potential harms of powerful AI models through licensing itself, rather than relying solely on external regulation or voluntary guidelines. But it also makes the legal landscape more complex to navigate.
Yeah, I can see how checking those restrictions would be vital. And speaking of licenses causing headaches, you mentioned it earlier, but there was that massive controversy with Stability AI's latest model, Stable Diffusion 3. What exactly happened there? It sounded like a real public uproar.
Oh, the Stable Diffusion 3 license controversy was a really stark illustration of just how critical licensing is to the community and to adoption. It was a mess, frankly, at the start.
What was so bad about the initial license?
When Stability AI initially released the weights for SD3, it wasn't under a standard open source license. It was under a very restrictive custom license they called the Creator's License.
Oh.
Okay. Restrictive how? Several ways. It imposed a monthly fee for commercial use, even for relatively small creators or businesses. It capped the number of images you could generate per month under certain tiers. But the most contentious clause, the one that really ignited the backlash,
Go on.
it required users to destroy all derivative works, meaning any fine-tuned models they had created based on SD3 if their license terminated or expired.
Wait, so if you fine-tuned the model for your specific art style and then stopped paying the fee, you had to delete your custom model. That sounds hostile.
It was widely perceived that way. A betrayal of the collaborative open-source ethos that had helped Stable Diffusion become so popular in the first place. The community felt like Stability was trying to lock down the ecosystem they had helped build.
So what happened? Did people just accept it?
Absolutely not. The backlash was swift and severe. Major community hubs, like Civitai, which hosts thousands of fine-tuned stable diffusion models, announced they would ban SD3 models released under that license. There was huge pushback on social media, forums.
Wow, the community really flexed its muscles.
They did, and faced with this widespread rebellion, Stability AI had to pivot, and fast. They quickly retracted the creator's license and replaced it with a much more permissive Stability AI community license.
What changed in the new license?
The new license removed the generation caps and the fees for individuals and smaller businesses, those under $1 million in annual revenue. And crucially, they clarified that users would not be required to delete their derivative works upon termination. It was much closer to what the community expected.
So they basically walked back the most controversial parts.
Pretty much entirely. And what's fascinating here is this whole episode was a powerful natural experiment. The technical capabilities of SD3 weren't really in question. By all accounts, it was a very powerful model. But its potential success, its adoption, was held completely hostage by the license.
The legal terms trump the tech.
In this case, absolutely. It showed that the community isn't just a passive consumer base. They are critical partners in value creation through things like fine-tuning, creating workflows, building tools around the core model, those network effects. It proved that thorough legal review and understanding the implications of a license are just as crucial as evaluating the model's technical performance. The license determines the long-term health and vibrancy of the ecosystem around the model.
That's a huge lesson for any company releasing models, open or otherwise. Okay, let's pull back again. What's the bigger picture here? How is this whole open source AI wave reshaping things on a larger scale? Everything from how individual developers work to how the big tech companies compete.
It's having a massive impact across the board. For individual developers especially, it's been profoundly empowering in many ways.
How so?
Well, first, they get direct, hands-on access to truly state-of-the-art tools. Frameworks like PyTorch, TensorFlow, platforms like Hugging Face with thousands of models. This accelerates learning incredibly fast. You can download a cutting-edge model and start experimenting immediately.
Lowering the barrier to entry for learning.
Dramatically. Plus, participating in open-source AI projects, contributing code, reporting bugs, sharing fine-tuned models has become a really important way for developers to advance their careers, build public portfolios, and gain recognition.
Makes sense. And what about day-to-day work? Are these tools actually making developers more productive?
That's a really interesting question, and the answer is complex. AI tools are definitely being used as powerful assistants. Think rubber duck debugging on steroids. Explaining your code problem to an AI can help clarify your thinking, or automating tedious tasks.
Like writing unit tests, boilerplate code, documentation.
Exactly. That stuff can be a drag, especially for more junior engineers. AI can really help there. So there's definitely a productivity boost for certain tasks.
But I sense a but coming. You mentioned it's complex. Is there a surprising twist to this productivity story? The productivity paradox?
Yes, exactly. While a 2024 survey found that nearly half of open source maintainers were using AI coding tools and felt positive about them, a quite rigorous randomized controlled trial published in 2025 yielded some surprising results.
Okay, what did the trial find?
They took experienced open source developers and gave them complex bug fixing or feature implementation tasks. Some used AI assistants, like Claude 3.5 Sonnet, some didn't. The finding was that the developers using the AI tools actually took, on average, 19% longer to complete the tasks.
Longer. That's the opposite of what you'd expect. Did the developers feel slower?
No. And this is the paradox. The developers using AI perceive themselves as being about 20% faster. They felt more productive, even though the objective measure showed they took more time.
Whoa, so they felt faster, but they were actually slower. That's almost ironic. Why would that happen?
The researchers hypothesized that for complex, high-stakes engineering tasks, the cognitive overhead involved in using the AI effectively can outweigh the benefits. Things like crafting the right prompts, carefully verifying the AI's suggestions, which would be subtly wrong, debugging the AI-generated code. That all takes time and mental energy.
So the back and forth with the AI adds friction for complex stuff.
It seems so. However, the study authors were quick to point out that this doesn't mean AI tools aren't useful. For more well-defined, modular, or perhaps lower-stakes tasks like customer support responses, generating routine code, writing documentation snippets, the productivity gains are likely very real and significant. AI assistants seem to be clear force multipliers there.
So effectiveness is highly task-dependent. Fascinating. Okay, but moving beyond individual developers, this open source wave sounds like an absolute dream for startups, right? Lowering barriers, enabling disruption.
Oh, absolutely. For startups and small businesses, open source AI is proving to be a powerful engine of disruption. First and foremost, it dramatically reduces costs.
We talked about licensing fees.
Yes, exactly. A Linux Foundation study actually found that smaller businesses adopt open source AI at higher rates than larger ones, specifically citing cost savings as a major driver, eliminating expensive proprietary software licenses, and crucially, the massive upfront investment needed to train a large model from scratch that really levels the playing field.
Allows them to compete where they couldn't before.
Right. It also democratizes access to advanced capabilities. Techniques have emerged like low-rank adaptation or LoRa and quantization. These basically allow you to take a huge, powerful open-weight model and efficiently fine-tune it on your own specific data or shrink it down to run on less powerful hardware.
So you don't need a supercomputer cluster to customize these models anymore.
Not necessarily, no, which is a huge win for smaller players with limited resources. And all this has fueled what some call a Cambrian explosion of AI-native startups. Well, Hugging Face itself is a prime example. They built their entire multi-billion-dollar business around hosting, serving, and building tools for the open-source AI community. You have companies like Fixie.ai building platforms to connect open-source LLMs to internal company data securely. And look at the startups, funded by accelerators like Y Combinator, Human Loop for LLM evaluation, TrueWind using AI for accounting, Magic Loops using generative AI for workflow automation. Many are built on or leverage open source foundations.
It really sounds like it's lowering the barrier to innovation. But what about the incumbents? How is this reshaping the corporate battlefield for the big tech players? They must be adapting their strategies too.
They absolutely are. The game has changed. The widespread availability of genuinely powerful open-weight models, think Llama 3, Mixtral, makes it very difficult, maybe impossible, for any single company to establish a durable monopoly purely at the model layer anymore. There are credible alternatives.
So they can't just rely on having the best model like OpenAI maybe initially hoped with GPT-3.
It's much harder now. This forces a shift in competitive strategy. Advantage isn't just about having a proprietary model behind an API. It's increasingly built by leveraging, contributing to, and shaping the open ecosystem, creating unique value on top of these models through specialized applications, integration services, building strong developer communities, providing the best infrastructure.
So it becomes more about the ecosystem than just the core tech.
Exactly. And this is where we see that strategic openness we discussed earlier used as a competitive weapon, particularly by players like Meta and Google.
How is it a weapon?
Several ways. First, by releasing powerful open-weight models, they aim to build dominant ecosystems, attract global developers, get them building on your platform, create those network effects we talked about, and establish your technology as a de facto standard. Make it the easiest, most capable free option.
Okay, build the community around your tech.
Right.
What else?
Second, it drives cloud consumption. While the models themselves might be free to download, running them, training them, fine-tuning them, that requires immense computational power. And guess who provides that power at scale?
The big cloud providers, including Google and potentially Meta down the line through partnerships.
Exactly. So free models can be a loss leader to drive billions in revenue to their cloud platforms. Third, it helps commoditize the competition. If you can get a free open-weight model that's almost as good as a competitor's expensive proprietary API model,
It undermines their business model.
it puts significant pressure on it. Why pay per token if you can run a comparable model yourself for just the compute cost, especially if you have the expertise?
This creates a really interesting dynamic, almost a paradox.
It does. On the one hand, you have this incredible democratization of AI application development, empowering startups and smaller players. But on the other hand, you risk further consolidation of power at the underlying infrastructure layer. The massive data sets needed for pre-training, the top AI research talent, and especially the sheer supply of cutting-edge GPUs. Those remain highly concentrated within a handful of tech giants.
So startups can innovate faster on the application side, but they might find themselves increasingly dependent on these giants for the essential computational fuel their innovations require.
That's the potential long-term tension, yes. It's a complex interplay between openness and concentration of resources.
This sounds incredibly powerful, transformative even, but every frontier has its dangers, doesn't it? This can't all be positive. What are the big risks, the challenges, the potential downsides that come with this open AI revolution?
You're right, it's definitely not all upside. The choice between using an open source model versus a closed source, API-based one, involves significant strategic trade-offs, and there are broader risks too.
Okay, let's compare them head to head on key factors. What about cost? We touched on this, but let's clarify.
Right. For cost, open source models typically have no direct licensing fees, and inference costs, the cost per query once deployed, can be significantly lower. We mentioned Llama 3 being potentially 10x cheaper per token than GPT-4 for raw inference.
Hmm.
But there are significant indirect costs. You need in-house expertise to deploy, manage, maintain, and secure these models. You bear the infrastructure costs directly.
Okay, so free license, but potentially high operational cost. What about closed?
Closed-source APIs offer predictable usage-based pricing, cost per token or per call. There's no upfront infrastructure investment, and maintenance and updates are handled by the vendor. But these API fees can become very expensive at scale. If you have high volume, the costs can skyrocket.
Makes sense. What about customization and control? That seems like a big differentiator.
Huge. Open source offers unparalleled flexibility. You can deeply fine-tune the model on your proprietary data. You have full control over the model's architecture, if truly open source, or its weights, and you control the deployment environment completely. But this requires significant technical resources and expertise.
And closed source.
Closed source is typically very easy to use out of the box with minimal setup. But you have very limited customization options beyond maybe some basic prompt engineering. And crucially, you have no control over the underlying model. The vendor can update at any time, which might change its behavior unexpectedly. This is known as model drift and can break applications.
Ooh, model drift sounds risky. Okay, transparency. How much can you see inside?
Open source generally offers more transparency. If the source code is available, it can be audited for biases, vulnerabilities, or other issues, which fosters community trust. But as we discussed, in many open-weight scenarios, the training data and methodology remain a black box, limiting true transparency.
We're closed.
Closed source means the model is a complete black box. You have no visibility into its inner workings, its potential biases, or the data it was trained on. You rely entirely on the vendor's documentation and assurances. The vendor is accountable, yes, but transparency is minimal.
Okay, two really critical ones for businesses: security and data privacy.
Right. For security and data privacy, open source models can be deployed entirely on premises or within your own private cloud. This gives you full control over your data. Sensitive information never has to leave your controlled environment. That's a huge plus for regulated industries or data-sensitive applications. But the public nature of open source code means malicious actors can also study it to find vulnerabilities more easily. And the organization deploying it is fully responsible for securing the model and the infrastructure.
So more control, but also more responsibility. Closed source.
With closed source APIs, the vendor typically manages the security of the model and provides a robust environment. That can be simpler. But you must send your data, potentially sensitive customer data or proprietary information, to the third-party API endpoint. This inherently creates compliance, privacy, and security risks that need careful management.
A fundamental trade-off there. What about support and maintenance if something breaks?
Open source relies heavily on community support forums, GitHub issues, shared knowledge. This can be vibrant and incredibly helpful. But there are typically no guaranteed response times or formal service level agreements, SLAs. That's a major risk if you're using an open source model for an enterprise critical application.
Yeah, you can't tell your customer, sorry, the community hasn't fixed the bug yet.
Exactly. Closed source vendors usually offer professional, dedicated customer support, often with enterprise-grade SLAs and regular managed updates. But this support can be expensive, often tied to higher subscription tiers.
Okay, nearly there. Innovation speed, which moves faster.
This is interesting. Open source can innovate extremely quickly in breadth, thanks to contributions from a global community experimenting in many directions. But this development can sometimes be fragmented or lack polish. Closed source models benefit from massive, focused R&D investment by the vendor, often leading to state-of-the-art performance on major benchmarks. But the pace and direction of innovation are gated entirely by the vendor's priorities and release cycles.
And finally, vendor lock-in. Getting stuck with one provider.
Open source largely allows you to avoid vendor lock-in. You can typically switch cloud providers, hosting environments, or underlying infrastructure more easily. Closed source APIs, by their nature, create a strong dependency on that single provider. Switching can be difficult and costly, requiring significant rework of your application.
Wow, okay. That's a really clear breakdown of the trade-offs. It sounds like there's no single best answer. It really depends on the specific needs and context of the organization.
Precisely. And this raises an important point. For many organizations, the optimal strategy might actually be a hybrid approach.
Mixing and matching.
Exactly. Maybe using closed-source APIs for rapid prototyping, for non-critical functions where ease of use is paramount, or where state-of-the-art performance is essential short-term, while simultaneously investing in building expertise and deploying open-source models for core, data-sensitive business processes where long-term control, customization, and data privacy are the top priorities.
That makes a lot of sense, using the right tool for the right job. But beyond these business trade-offs, the very accessibility and openness of these models, even open-weight ones, makes them potentially powerful tools for malicious actors too, right? It feels like a classic double-edged sword.
It is, absolutely. And this is a major area of concern for governments, security agencies, and researchers. The most pressing cluster of risks falls under malicious use and weaponization.
What kind of malicious use are we talking about?
Several categories. There are significant cybersecurity threats. These models can lower the barrier for creating novel malware, automating the discovery of software vulnerabilities, or crafting highly convincing, personalized phishing emails or social engineering campaigns at an unprecedented scale, making attacks cheaper and easier to launch. Scary stuff. What else? The risk of disinformation and deepfakes. Open models can be fine-tuned relatively easily to generate propaganda, fake news articles, or hyper-realistic deepfake images and videos. These can be used to influence elections, incite social disorder, harass individuals, or generally undermine trust in information sources.
The ability to fake reality convincingly at scale.
That's the fear. And there are even concerns, though perhaps more speculative at this stage, about physical and scientific threats. Could open models accelerate the development of autonomous weapons systems? Could they inadvertently help malicious actors develop harmful chemical or biological agents by, say, summarizing complex scientific literature or suggesting experimental pathways? These are active areas of debate and concern.
That's genuinely alarming. Okay, besides outright malicious use, what about risks related to the data these models use or their operational integrity?
Those represent another significant set of challenges: data, IP, and operational risks. A major one is data provenance and copyright. As we mentioned, many large models are trained on vast data sets scraped from the internet. It's often unclear exactly what's in that data: copyrighted material, incorrect information, toxic content, maybe even private data that shouldn't be there.
So using a model trained on dodgy data could lead to legal trouble.
Potentially, yes. An organization using such a model could face legal liability down the road if it's found to be infringing copyright or privacy regulations. The legal status of AI-generated content itself, in terms of copyright ownership, is also still very ambiguous in many jurisdictions.
A legal minefield. What about securing the models themselves?
That's model security and integrity. Because the code or weights are often public, open models can be vulnerable to specific types of attacks. Data poisoning is one, where an attacker subtly inserts tainted data into the training set, or fine-tuning data, to corrupt the model's behavior in specific ways. Prompt injection is another huge concern.
Prompt injection, what's that?
That's where an attacker crafts a malicious prompt that tricks the model into bypassing its safety features or instructions. They might fool it into revealing sensitive information it shouldn't, generating harmful content it's supposed to refuse, or even executing unintended actions in connected systems.
So you can hijack the model through clever wording.
Essentially, yes, it's a major vulnerability. Then you have ongoing quality and reliability concerns. Models are prone to hallucinations, confidently generating outputs that sound plausible but are factually incorrect or nonsensical. This can obviously damage a brand's reputation or lead to terrible decisions if relied upon uncritically. And the quality and security practices can vary wildly between different open source projects.
Not all open source is created equal.
Definitely not. And finally, there's the issue of lack of accountability. If an open source model causes harm, who's responsible? Is it the original developers, the community contributors, the organization that deployed it? Assigning liability can be very difficult due to the decentralized nature of many projects.
Okay, that's a daunting list of risks. Given all that, how should organizations approach using open source AI responsibly? They can't just ignore it, but they can't ignore the risks either.
It demands a very deliberate, proactive, and robust governance framework. This framework needs to integrate technical, legal, and ethical considerations from the very beginning. It's not something you can bolt on later.
What does that look like in practice?
It starts with rigorous due diligence before adopting any open source model.
Yeah.
First, license scrutiny, really understanding the terms. Is it compatible with your intended commercial use? Are there any unacceptable restrictions or obligations? That Stable Diffusion 3 example shows why this is vital.
Lesson learned there. What else?
Provenance investigation. Who actually developed this model? What's their reputation? What's known or not known about the training data and methodology? Look for projects with more transparency, like those from reputable research labs or initiatives like Eleuther AI or Big Science. And community health assessment. Is the project actively maintained? Are the maintainers responsive? Is the project stable or likely to be abandoned?
So really vetting the source. Then what?
Then you need strong security best practices during implementation and deployment. Treat AI models like any other critical piece of software like code. Subject them to regular vulnerability scanning, code reviews if possible. Implement defensive prompting and filtering. Use multiple layers of input filters to catch malicious prompts. Strictly validate outputs to guard against prompt injection and harmful content generation.
Building safety layers around the model.
Exactly. And ensure secure and isolated deployment. Ideally, host sensitive applications using open source models in a secure, isolated environment, like a private cloud or on-premises, where you maintain full data control. Apply the principle of least privilege. Give the model only the access it absolutely needs.
It sounds like adopting open source AI safely requires significant maturity in security and governance.
It absolutely does. It's not a shortcut to avoid responsibility. In many ways, it increases it.
This has been incredibly insightful on the technical and business aspects. But stepping back one last time, this is clearly more than just a tech trend. It feels like a genuinely transformative force. What are the potential long-term consequences for our economy, for society as a whole?
That's the billion, maybe trillion-dollar question. Most economists and technologists now view generative AI as a potential general-purpose technology, or GPT, no relation to the model acronym.
Like the steam engine, electricity, the internet.
Exactly. Technologies with the capacity to fundamentally alter economic growth trajectories and transform society. The core impact of generative AI is on automating or augmenting cognitive tasks. Estimates suggest this could affect tasks performed by nearly 80% of the U.S. workforce, with some studies suggesting potential to perform maybe 10% of workplace tasks more than twice as quickly.
That implies a huge potential productivity boost.
It does. We're seeing projections of a significant productivity boom. Studies are already showing large gains in areas like customer support, software development, R&D, potentially 10–15% or more in some cases. This could be a major engine for economic growth, potentially counteracting slowing global productivity trends.
But productivity booms driven by automation always raise questions about jobs, don't they?
Always. And this time might be different. This wave promises significant labor market disruption. Unlike past waves of automation that primarily affected routine manual tasks, generative AI directly targets non-routine cognitive work.
Work previously thought safe from automation.
Right. We're already seeing some early, albeit preliminary evidence. Studies of freelance platforms like Upwork show writers and graphic designers experiencing a noticeable decline in contracts and earnings following the release of ChatGPT and powerful image models.
So the impact is already being felt by some. How might this play out more broadly across the workforce?
The concern among many economists is that it will create a polarization effect, potentially exacerbating income and wealth inequality.
How so? Who wins and who loses?
The thinking is that high-skilled workers, those involved in complex problem-solving, creativity, strategic decision-making, will likely complement AI. They'll use it as a tool to augment their abilities, increasing their productivity and potentially their wages. At the other end, some argue low-skill or entry-level workers might benefit from AI as an upskilling tool, providing on-demand information and guidance, improving their performance.
Okay, so high and low ends might benefit. Who's squeezed?
The group potentially most vulnerable seems to be mid-skill knowledge workers. Those performing routine but cognitively intensive tasks, think certain types of analysis, report generation, data entry, billing, payroll, some aspects of management. These roles face the highest risk of significant task automation, displacement, or downward pressure on wages.
That's a huge swath of the modern workforce.
It is. And while proponents argue that, like past GPTs, generative AI will eventually create new jobs we can't yet imagine, the concern is the speed of this transition might be much faster than previous technological waves. The adjustment could be very disruptive.
Which puts pressure on.
It creates an urgent imperative for policymakers. We likely need massive investment in workforce retraining and reskilling programs, lifelong learning initiatives, and potentially a serious rethinking and modernization of our social safety nets to support people through this transition.
A huge societal challenge. Now, the economic upside you mentioned sounds massive, trillions of dollars. But there's a growing shadow to that upside, isn't there? The environmental cost. That's a side of AI people don't often talk about.
You're right, it's often overlooked, but it's becoming a major concern. There is a significant and rapidly growing environmental footprint associated with the AI boom.
In what ways?
Primarily electricity consumption. Training these enormous models, and increasingly running them for inference day to day, is incredibly energy intensive. Data centers powering AI are projected to potentially more than double their global electricity consumption by 2026, reaching nearly 1,050 terawatt hours.
How much is that in real terms?
That's an amount somewhere between the entire annual national electricity consumption of Japan and Russia. Just training GPT-3's precursor was estimated to consume around 12,287 megawatt hours, roughly the annual power consumption of 120 average U.S. homes. And remember, inference the day-to-day usage will likely dwarf training energy use over the model's lifetime.
Wow, just staggering amounts of power. What else?
Water consumption. This high-performance hardware generates immense heat and requires vast amounts of water for cooling, primarily in data centers. This can put significant strain on local municipal water supplies, especially in water-scarce regions, and disrupt local ecosystems.
So energy and water.
Yes. And third, the hardware lifecycle and e-waste. The intense competition and rapid pace of innovation mean a very short shelf life for both the AI models and the specialized hardware, particularly GPUs, needed to run them effectively. This constant demand for newer, more powerful hardware drives significant environmental impact through manufacturing, transportation of components, and ultimately disposal of outdated electronics e-waste.
It sounds like the current trajectory chasing ever larger models might be environmentally unsustainable.
That's the growing concern. It requires a much more comprehensive assessment, balancing the undeniable benefits of AI against its full environmental and societal costs. We can't just look at the economic upside in isolation.
That's a really sobering thought to end on. It means we can't just blindly chase the benefits of this open AI revolution without confronting these significant and potentially concentrated costs, can we?
Exactly. And that brings us back to the central paradox we've seen throughout this discussion. While many of the benefits of AI in the productivity gains, the innovation, the new tools are being widely distributed, thanks in part to open source, the costs and the risks seem to be becoming increasingly concentrated.
How so?
The environmental burden, energy and water use, is concentrated in the communities hosting the massive data centers. The economic cost of job displacement, if predictions hold true, could disproportionately affect mid-skill workers, potentially worsening inequality. And the security risks from malicious use fall broadly on society as a whole.
And the term open itself can be a bit misleading.
Right. As we discussed, open often masks strategic corporate interests aimed at capturing users and developers within larger proprietary ecosystems, particularly at the crucial infrastructure layer, the cloud platforms, the specialized hardware. It's not always about pure altruism.
So the path forward, the long-term sustainability of this whole movement, it requires some serious collective thought and commitment, doesn't it?
It absolutely does. It depends fundamentally on a collective commitment to responsible stewardship. That means developers building security, ethics, and efficiency into the tools and licenses from the start. It means businesses implementing rigorous governance, doing their due diligence, and thinking critically about the trade-offs.
And policymakers.
Policymakers have a huge role in creating intelligent, adaptive regulations. Regulations that promote energy efficiency and AI, that manage the risks associated with the most powerful models, that support labor transitions and update safety nets, all without stifling the incredible innovation potential. It's a difficult balancing act.
A balancing act indeed. So for you, our listener, as you watch this space continue to evolve at lightning speed, what aspects of this complex, powerful, and risky open frontier of AI will you be watching most closely? That's something to ponder.